So hi guys, in this video we will be going to look at MergeSort. We will be looking at the functionality of the MergeSort and the time complexity, and then we will be writing the code for the same, right? So without a delay, let's start. So like MergeSort is basically a sorting algorithm, we all know, right? It's based on divide and conquer approach, right? So what's happened in that approach is we will divide our problems from into smaller sub problems, right? That actually same like in recursion, right? And then we will be combining mm, mm, the smaller sub problem solution. So let's suppose we have broken down this smaller problems, and we will find out the solution for this smaller problem, and then we will make our actual solution, right? So that's how the roughly idea how MergeSort like divide and conquer is working, right? And so let's start with one very first example. So yeah, in MergeSort we will be doing this same approach, right? So let's suppose we had an array. Let me highlight with the red one. So let's suppose we had an array 1 2 3 4 5 6 7 8 8. So here we had 8 elements, right? So we had 8 element here. So what we will do is we will find out the break down this n problem to n by 2, right? So we will break down this problem into two halves of n by 2 and n by 2. So let's find out the middlemost elements. Let's call this index at l, and let's call this index as end, right? So this is l and this is n. So this is 0 and this is 7. So if you calculate the middlemost element, it would be nothing but 7 divided by 2. 0 plus 7 divided by 2 is nothing but 3, right? So 0 1 2 3. So here this is our middlemost element, right? So what we will be doing here is we will divide this arrays into two half. One is this half, so one is from uh, L to M, and then another half is from M plus 1 to N, right? So this is the two half. So we divided our problem into two half, and then what we will be doing, we will be further dividing. So right, so what we will be doing here is uh, we will be simply making a recursive call on this sorter half and this sorter half, and then finally, so what the recursion will do here is, here our assumption is recursion will sort this smaller subproblem, and then we will finally derive our actual answer. So let's suppose uh, let's suppose the recursion will solve this whole problem, right? So let me rub it out. So let's suppose, so you had an array like this. Here is 38, here is 27, here is 43, and here is 3. Here goes 9, 9 and 82. Then we had 10, right? So we will divide our problem into half. Here was 38, 27, 43, and 3, and the rest of the element goes in this part: 9, 82, and 10. So what's happened is recursion will solve this part, right? So this is our assumption here. So after solving this part, our array becomes 3, 27, and 38, and 43, right? So yeah, sorry for the bad writing here, and this part becomes 9, 10 and 82, right? So yeah, recursion will solve these two halves, and then we need to combine derived our actual answer, right? So yeah, so we got this two half, and then we will, so the most important part of merge sort is merging, right? How the merge operation is performed, right? So we will be also looking into that, right? So let's assume we had sorted this array, and now we need to merge these two parts, right? So 337 and 38 27 38 43. So let's go there. So let me just write it out once more time. 3 37 4, sorry, not 37, it's 27, sorry, 27 and 38 43, and here we have 9 10 and 81, 81 or 83. So we had 82, 82, sorry, we had 82, we had 82 here, right? So this is our two half. So what we will be doing here is, so this is, let's suppose here, here is our lower bound, and this is middlemost element, and this is our end element, this is middlemost element, right? So what we will be doing here is, so we will put these three variables, right? So what we will do, we will compare the first element of the first half with the second element, the first element of the second half, we will compare which is smaller, right? And we will create a temporary array, right? We will create a temporary array, and we simply assign the value based on their comparison, right? So here 3 is smaller than 9, so 3 goes here. Again we will increment, let's suppose I is pointing to this array and j is pointing to this array, right? So what we will be doing here is, we will compare this 3 will, like, array of I with array of j. If it is smaller, right, then we will be incrementing I value. So I comes here, and j remains here, and then we will compare 27 with 9, so 9 goes here, and then we will be incrementing j pointing to here, and then we will be comparing with 27. So yeah, it's smaller, j goes here, and then we will be comparing with 27, j2 with 20, yeah, 27 is smaller, 27 goes here, and then we will be comparing 38 with 82, 82 is smaller, this goes here, and then 43 goes here, and then we will be, so this half is exhausted now. We are left with only this element, right? So this element we are left with, and we will simply assign this element, right? So in final we got our actual uh, sorted array, right? So we have done this part. So but if you see how recursion is proceed in this question, so how recursion is proceed in this question, so it will again divide this half into smaller halves, right? So here you can see, right? So we had this smaller half, this smaller half here is again divided into two halves, and again this half, this first half is again divided into two parts, right? 38 and 27, right? And we know that if an element containing only one element, right? So let's suppose any element, let's suppose 81. If it is one element, it means the lower bound and the starting index and ending index is pointing to the same element, right? So this condition is actually false, right? So we will do nothing in that case, right? When we have only two elements, then we will do partitioning and all those stuff, right? So in that case we will simply return it, right? So uh, we have this element, this half, so it will be written, and this half it will be written, right? So we are just left with then we need to do the then we need to do the comparison, right? So we got this 38 and 29 in our recursive code. So let me just give you the format so you can like easily understand, right? So the syntax would be look like this, right? So here let's suppose this is our merge sort, right? And here we have array, here we have our start, here we have our end, right? So what we will do, we will check if our start is less than end, then we will be doing all the stuff, right? So if in that case, then we will find middle element. Middle element is nothing but start divided by n2, and then we will call merge sort on this part from start to middle, and then we will call merge sort on middle plus 1, middle plus 1 to end, right? And then we will finally proceed with our merge operation, right? Merge operation, we will pass start and end, right? We will pass our start, and even we have to pass this middle and end, right? So yeah, so that's, so what I'm trying to prove here is, let's suppose you have only two elements, right? Let's suppose you have only two elements, 27 and let's suppose 15, right? So in that case, start is pointing to here, right? Start is pointing to here and end is pointing to here, right? So in that case, start is always less than n, right? 0 is less than 1, so we will be calculating middle. So what will be middle? Middle is nothing but 0 plus 1 divided by 2. It's nothing but 1 divided by 2. We will get 1, we will get 0, sorry, we will get 0. So it will be merge routine will call on this part and this part, right? 27 and 15, and we actually this condition false, and this statement then execute this statement is, and now we need to perform our merge operation. So what we will be doing, we will be creating a temp array. So what should be the size of temp array? Temp array size would be nothing but and minus, so here we need to create a size of 2, right? So and minus star plus 1, right? So we will be comparing, we will be creating this array, and now what we need to do here is, and now what we need to do here is, let's suppose, so we had this two half, and now what we will be doing here is, we will be creating two pointer I and j. So I will be pointing, so I will be pointing to the lower index. Let's say this is start, no? Yeah, start, and j will be pointing to middle plus 1, right? Middle plus 1, and then what we have to do, we will create a variable k, which is we used to assign the value. We will check, right, while our I is less than equal to middle and r j is less than equal to n, right? And we will do if a of I, right? A of I means this element is smaller than A of j, right? A of j, which in our case is not, right? So we will be else, right? Else A of j, A of j means 15 is smaller than yes. Then in that case, what we need to do here is we will be assigning A of k to A of j, and we will increment both j and k, right? J and k, we need to increment both, right? Need to increment both, and in that case we need to do reverse operation, right? So yeah, so after that j is pointing actually j is pointing one greater than to end. So what we will do here, so we had two cases, right? One case would be this array is exhausted and some of the element of this element of first half is left. We need to just copy into the temp array, right? And might be reverse case also be possible. So this whole array is exhausted, we are left with some of the element of this part, then we need to copy this element in the temporary, right? So hope you got the idea, and it will be more clear to you once I write down the code. So what should be the complexity of merge sort, right? So what we are doing here is, if you see, merge sort is like this, right? Merge sort is like this. So here we already write. So we are dividing our array. So let's suppose if the size of the array is n, we are dividing into two equals half, right? Of n by 2 n by 2, right? And then we are performing a merging operation, and in merging operation what we are just comparing element and assigning into one array. It's kind of a iterating over in this part, so it's kind of an on work we are doing, right? On work we are doing, right? And if you write the recurrence relation, it would be like t of n would be nothing but t of n by 2. So we are dividing our problems into 2 times n by 2, and we are performing on operation, right? Merging operation, merge operation, right? And if you simplify it, it will become 2t n by 2 plus order of n, right? Or you can say cn, right? And if you solve this recurrence with master theorem, it will be nothing but order of log n. So yeah, that's the complexity in all cases. Best, worst, and average cases, it remains log n, right? So yeah, so let's try to jump into the code, and let's see if we able to